Hai, Assalamualaikum dan good morning. I don't know, good morning, good afternoon. This is my video number 28, I think. Yeah. Right, we'll talk on curl and divergence. Okay. Now, let us define the operator del operator. So we define del operator as this: del x, del y, del z. Right? We know this thing. You know it. Okay. So this operator del, without any function attached to it, it gives no meaning. But once we attach to a function to it, then it gives a meaning. For example, if for any scalar function f, yeah, which is f is x, y, z, then del f, you know this, right? Del f given as del f del x, del f del y, del f del z. Okay, this we call it as a gradient vector. Oh. Okay, so yeah, we have seen in my previous video, if this is a function or surface f x, y, z, then del f is a normal to that surface at any point, and normal to that surface, maybe here is normal to the surface. This is del f. Now, for curls, we define if a vector field f with component pqr, then we define curl f or curl of f as del cross f. And del cross f, this is f. This is how to find this. Del cross f, where I, j, k. Del is del x, del y, del z. Yeah, and f is pqr. Okay, so this will give you. So what we have, del q del z minus del r del y. This is for I, and then for j we have del p del z, del p del z minus del r del p del z, or del r del x. All right, and for k, so we have del q del x minus del p del y. So that's the definition of curl. And we have one more, is that the divergence. For the divergence we have another definition. if f, bear in mind that PQR must be differentiable. Yeah, PQR must be differentiable. So let f with PQR, then we define the divergence denoted as diff of f. This is given as dot f. Okay, so if we substitute everything there, del with del x, del y, del z, and f is PQR, then we have this given as del p del x plus del q del y plus del r del z. Okay, that's the definition of curl and divergence. Now let me give you some example. Okay, so let's say we have, this is very simple example, just a direct application. Let's say our f is given as xz, xyz, and minus y squared. Then find curl of f and divergence of f. Okay, so for curl of f, we use the definition curl f. This is del cross f. All right, so this is, you can just ijk. For del, we have del x, del y, del z. Okay, for f, we have xz, xyz minus y squared. This is equal to, for I, so we have del y minus y squared. Yeah, I do it one by one. Minus del z x y z. Okay, for j, so we have negative of del x, negative j, negative y squared. For I, oh, this is wrong. Yeah, correct. So for this del x, negative y squared minus del z, xz. Okay, and for z, for k, so we have del x, xyz minus del y, xz. Okay, then you can perform this operation. So that gives you, this one is that's negative y squared, negative 2y, right, negative 2y. Here you have with z minus xy. For that we have negative 2y, the x is 0, z, this is, you got negative x negative negative is positive, so we have x there, correct? Yeah, this one is 0, there's negative negative, you got positive, and for that, so we have yz minus 0, so that's we have. Okay, and then for divergence of f, this is by definition is del dot f, that give you del del x, del del x, del del y, del del z, dot f is xz, xyz minus y squared. Okay. Right. So if you perform this, so what we have, this is del del x xz, so we have z plus del del y xyz, that gives you xz plus del del y 0, that gives you 0. So you have z plus xz. You can simplify if you want, 1 plus x. So if you look at this two operation, curl and div, curl and divergence, so what we find, curl will give you vector, divergence will give you a scalar. This is scalar, so don't get confused with this. Okay, don't get confused. Some theoretical aspect that we might want to know. I state without proof because this one is quite simple theorem. If f is a function of 3 variables, so let's say f is a function of x, y, z, function of 3 variable, that if f has a continuous second order derivative, if f has continuous second order derivative, then curl of f. How do you read this? This equal to 0. Now how do you read this? This is curl, alright, this gradient of f. So curl grad f. Okay, in terms of notation, you can write this curl, we have that, and grad of f. Okay, it's not difficult for you to show this, because gradient of f is, this is a vector, this is del f del x, del f del y, del f del z. So don't get confused. So we have, up to now we have 3 ways of using del. First thing is gradient, second is curl, third is divergence. All give different result, different way of using it. So really don't get confused with that. And basically just use a simple vector operation. Okay, so back to this, how to prove that. So whereas del f is there, then curl f is curl of del f. So we have del cross that. So you just need to arrange those things. That will give you 0 straight away. So that's not the big deal. Okay, so I leave there. If f is conservative, if s is conservative, conservative vector field. So there exists a potential function. We have met this earlier. There exists a potential function f such that del f is equal to f. Remember that we call this f as a potential function. Potential function. Okay. If you look at this, conservative, look at f conservative, we have this relation. See what happens if we substitute into curl of f. Okay, substitute into that. So what will happen? Curl of f. Okay, that give us curl of del f, right? Because f, in this case, there exists f such that that relation is true. So what we did here is just satisfy f with del f, and this capital F vector vector field. This is a scalar function f. Okay, so that will give you 0. That will give 0. Why 0? Because we already have theorem here say that curl of del f is 0. So which means this part give you 0. So when curl of del f is 0, or curl f is 0, or curl f is 0, those things, curl f is 0. So from here, from this statement, yeah, from all this statement, when curl f is 0, so f is conservative. F is conservative. Okay, conservative. Conservative vector field. So if you proceed this conservative vector field using that relation, what we have? So what do we have? Curl of f. Where do I write? Just now. Curl of f. Where is it? So we have curl of f. Curl of f. This is, we have del q, del z minus del r, del y, del p, del z minus del r, del x, del q, del x minus del p, del y. This for f is conservative. Okay, for f conservative. For f conservative. Conservative vector field. So we have this curl f. That's the definition of curl f. That equal to 0. Why 0? Because f is conservative. So what I want to show you here is that what is the relationship to be fulfilled, or what the condition to be fulfilled if f is conservative. So we have this since f is conservative, curl is 0, and from there you can equate the component of each of those vectors. Then we find that del q del z is just equal to del p del y. Yeah, because this item is 0, this component is 0, that component is 0. So we have del p del y, del p del z. This is equal to del r del x, and del q del x equal to del p del y. Alright. So this gives a relationship or a condition that f is conservative. Now, if you want to show that either the given f is conservative or not, what you need to do is show those components. Okay, you just need to show the component. All right. Let's give an example. Okay, example. If we have f is given as that exact the previous example. This is the function that given in the previous example. Yeah, the vector fact given in previous example. X, Y, Z and minus y squared. Okay, show that this is not conservative. It's not conservative vector field. So using this condition here, okay, using this condition here, so it is not difficult for you to show that. Okay, so this is P, this is P, this is Q, this is R. So what we need del Q del Z, del P del Y. So del Q del Z, del Q del Z. So del Q del Z, that give you del Q del Z, that give you XY, and del P del Y, del P del Y, del P del Y, this is 0. So you can see here that del Q del Z is different than del P del Y. Okay, one of the component is not satisfied, so we can say f is not, therefore f is not conservative. Okay, or you can also show, or you can also do this. Curl of f. If you find the curl of f, okay, find the curl of f with given f that, okay, find each of these component, first component, second component and third component. Each of this component will not give you 0, so this is different than 0, so therefore f is not conservative. It's not conservative. Okay, you can try that. For example, the first component here is that del Q del Z minus del P del Y. So xy minus 0 is xy, so it's not 0. You can find the second component, you can also find the third component. So therefore f is not conservative. Let's for other example, let's say f is y squared z cube, y squared z cube, 2xyz cube, 3xy square, 3xy square z squared. Okay, is this conservative? Conservative vector field? You can check this. Okay, check. How to check? Just find the curl, show that they equal to 0 if it is conservative. Okay, so curl of f, that give you that. You can use the previous relation that you use, that we have, or use the fact that curl of f must equal to 0. You just find it. Okay, so we have I, j, k, del x, del y, del z, that y squared z cube, 2xyz cube, 3xy squared z squared. Okay, so that give you for I del y. So we have 6xyz squared minus for I. Okay, correct. So we have del z with that. So 6x y z squared. Okay, so the first term here, this is 0. The second terms, you can find it. So that basically this also give you 0. This part also give you 0. So therefore this is 0. So therefore f is a conservative vector field. Okay. So another problem that we could think of is that if given f is conservative, the previous case, our f given, or we have showed that basically this f y squared z cube 2x y z cube 3x y squared z squared. Okay, the previous example, f given in the previous example, we show that this is conservative. Given that is conservative vector field, then find the vector function, f such that del f is equal to f. Okay, so can I leave this as an exercise to you? Let's begin with that. Del f, this is del x, del f del x, del f del y, del f del z equal to f. Our f is y squared z cube 2x 2xyz cube 3xy squared z squared. Okay, equates each of these components. So what we have, equate each of those components. What we have del f del x is equal to del f del x is equal to y squared z cube. Okay, let's call this first equation. Del f del y is equal to 2xyz cube. Let's call the second equation. Del f del z is 3xy squared z squared. Let's call this third equation. Remember that, bear in mind, we want to find f. From this, you can find f by integrate with respect to x, integrate with respect to y, integrate with respect to z. Correct? So let's do it one by one. From 1, we integrate with respect to x. Yeah, integrate with respect to x. So I can say integrate 1 with respect to x. So what we have, left hand side, we got f. F here is a function of, remember the function of x, y, z. So look at here, function of x, y, z. So x, y, z. This is equal to, differentiate that with respect to, integrate with respect to x. Integrate with respect to x. So we have y squared z cube x. Or I can put x here. Plus function. This is function of three variables. Function of 3 variables. One of them is here. So another one is function free of x. So let's call that function, let's call that phi 1 function of yz. Why we have yz here? Because if we differentiate this with respect to x, this gives you 0, then we will have the same function again. You cannot make it as a constant, because this function of 3 variable, yz is free of xy. Yz is free of x. Okay. Now, having done that, I can differentiate this. We need to find what is phi 1. We need to find what is phi 1. So we differentiate that with respect to what? Look at this equation that we have. We have del f del y. We know what is del f del y. So I can differentiate that with respect to y. If I differentiate with respect to y, del f del y, that gives you 2xy z cube. Differentiate that with respect to y. So we have plus del phi 1 del y. This is yz. Okay. And equate to 2. Our 2 is 2 x y z cube. Okay.